How's everyone doing? Well, I'm Evan Clark from 224 up in Loveland, and I'm a Life Scout, hoping to be an Eagle Scout. You were wrong, sir.
Oh.
I'm not there yet. But
I'm sorry, it was the Eagle Scout project. I apologize.
yeah. So, this is basically a summary of my project. So it's for LTO. It's going to be a scale solar system, but only distance. So you can really see how far stuff is apart. And also size is kind of a pain. So nitty gritty, it's going to be post in the ground. It's going to have information about the planet and the planet. It's going to be amazing. And so the observatory will be the sun, and then the planets will wind down the path they came up. I put a gray dot there because I was too lazy to put in all the terrestrial planets, but they're all going to be in there, and then Jupiter, Saturn. And there is going to be 9 planets because there are 9 planets.
That's after both talks tonight, though? Now?
Well, as of now. So please give me there's a gold donation box for my project. Any amount helps. Thank you. Also, I'll be back after the talk for questions.
Yeah. All right.
Choice, donate to Evan tonight, please.
All right, so what I've been doing for much of this last year is a little warm-up talk before we've had our presenters speak. And so tonight I'm my own warm-up act. So we're going to talk about Tabby's star or Boyagin's star. I don't know exactly. Thank you very much. Is it an alien megastructure? We'll talk about that. But first, we did lose Stephen Hawking March 14th. And I didn't have time or give it thought or read my email to see the suggestion to do a memorial for him tonight. So I'm going to try to do something unique and LTO like for him next month. So I'll work on that. But great mind and incredible contributor to physics and astronomy, and we missed. All right, so Tabby's star is an interesting little star that kind of poked its head into the news now and then because one astronomer published a paper saying that he thought there might be aliens building giant structures around the star, making it look odd to us. And so we have some ideas. We're going to go through what they might be, what makes the star look odd. But let me cover some of the background here. So in 2010, it was this statement of bizarre peak, a giant transit, was posted in an online forum. The initial study was conducted by Tabitha Boyagin, so that's why it's Tabby's star. And this is one of the stars that the Kepler mission, was studying at for its primary 4-year-long mission before its control systems failed and it couldn't continue to point in that part of the sky. Kepler is still operating, it's just working in a different part of the sky, being controlled differently. But during those 4 years, 15 terabytes of data got sent down to Earth, looking at stars, staring at the stars for this entire time, watching for dips in the light of stars. It would mean that something went between us and the star. And from that, we were able to determine over 4,500 candidates for other solar systems, for planetary systems around other stars. Well, a lot of them were easy to follow up on and had good signals, and the astronomers jumped on those, and it's sort of the low-hanging fruit of the study. But a lot of the cases are really marginal, right down in the noise of barely be able to detect things well. So they formed what's called a citizen science project called Planet Hunters, and just turned the data over to whoever wanted to sign up and play with the data themselves. So one of the users, Copernicus123, and it's a good thing he had a nice name that could be repeated in public, noticed that unusual dip. 2 years later, there's even a greater dip where 15% of the starlight went away in 5 days. So the discovery was announced in April of 2016. We had the star with a very weird light curve. Now, if a planet is going to go around the star, let's say once every 8 months, then every 8 months you get a nice dip. It's very regular and very, very understandable. If you have sunspots or something, which other stars do have sunspots, sunspots will go around maybe once or twice on the star, and so you'll get maybe a little bit of a strange light curve, but it'll still have some regularity to it. Well, this did not have regularity. You had 10 dips. Some lasted days, some lasted weeks, to where 0.5% to 20% of the star's light was blocked. It was bizarre. No other star had looked like this. And after that, the star would go back to its full brightness. So here's an example or a segment of the light curve we got from it. Look at some of the weird behavior and all that crazy stuff there, kind of magnified down here. Just stuff we'd never seen before. So what put it out into the news was Jason Wright, Penn State University, published a paper saying that this could be the result of the work of aliens building stuff. Now, Kepler is no longer pointing this part of the sky, so we can't get data from Kepler to continue to watch it. We can watch from Earth, but the smallest dips that could be detected from Kepler, we can't see through this murky atmosphere. So we can get big dips. We could see the larger dips of the star if they happen, but they haven't. Nothing has come back. So what is this star? The star is a sort of midlife F-class star. We are a G-class star. So it's a little warmer, a little hotter star, about 50% larger than our sun. We've done a lot of studies on it now. Looking at it, we see no wobble, as if there were a black hole around it, or maybe another star or a dwarf or something going around it. So we don't think that's going on. Other stars show regular dips, but they're young and they have dust disks, and we look in the infrared and we don't see any sign of a dusty disk around it. So right away, the weirdness intensifies. But looking further back, we have plates taken from the early days of photographic astronomy, showing that the star has dimmed 15% between 1890 and 1989. Stars don't do that we know. Others have looked at the data and think that that's probably actually errors in how the plates were processed and non-standard things that occurred over time. But even the Kepler calibration frames, which they don't throw any data away at all, shows the star overall got about 3% dimmer over 4 years. So what could be doing this? So astronomers jumped on all sorts of favorite models, trying not to go to aliens as the first reason. Could be something inside the star. Maybe this star is really close to the end of its life, and it's about to transform into a red giant, go on to the next phase. Well, this is a process that should occur over thousands of years. We don't expect dips and weird things to happen over just a few years or months. So that kind of makes that unlikely. Could it be giant sunspots? Well, for best we understand sunspots and the sunspots we've seen on other stars, for a star bigger than this, it would actually be, the sunspots would be confined to a smaller size than what we have on ours. And the sunspots do go around at least a few times, making a regular light curve. So it's unlikely that it's unusual sunspots or even giant sunspots. So inside the star or on the star itself is kind of discountable. So what about the area or in that system right around the star? Well, if you had close objects like dust clouds or a planet that has broken apart or collided with another body in the system, this material close to the star would get hot. We would see an infrared signature from it, and I already pointed out that we don't see anything unusual happening in the infrared, in the thermal or heat part of the electromagnetic spectrum, so that's pretty unlikely. Someone put out the idea that it may have swallowed one of its own planets, a larger planet, maybe in the last 10,000 years, and brightened, and now it's dimming off of that. We just don't have any data from back then. But again, you probably would have leftover debris, asteroids, gases, dust, and we don't see any of that material in the system. So it's pretty unlikely that that would be the cause of this. How about dust clouds or objects further out in the system, maybe in the Pluto region or our Kuiper belt equivalent? Well, this would be colder, so the infrared signature wouldn't be as strong, but we've gone back and looked even closer in the infrared and still see nothing unusual. Even cold material out in the Kuiper belt would be warmer than empty space. Unless this gas cloud was on a really elliptical orbit, something really unusual, getting this kind of light curve behavior is still unlikely. So we do have to throw in here what's called a Dyson sphere or an alien megastructure. Alien megastructure could be any shape that you need to explain the funny dips, so that helps there. It's not really the way we do science, but it too would have an infrared signature. If you had some giant structure made out of all the planets that used to be in the solar system, some ring out here at the distance of Earth or a little further because it's a hotter star, or some massive bands that an alien's built around it, or some huge planetary structure out here, they'd have to go to other solar systems and pull whole planets in to make something with this much material in it. We would see an infrared signature. It would be different, it'd be unusual, but it would be there, and we don't see any evidence of that. All right, so how about between that star and us in interstellar space? Looking at the spectrum of Tabby's star, we do see that there are at least 2 interstellar gas clouds between us. And we know that about a quarter of the light never makes it to us from the star in the first place because of these gas clouds. And you could have clumps of gas and dust just traveling through space that happen to go in front of this star from our point of view. And it wouldn't be regular, it would just be whatever clumps happen to move by. So that actually puts it in the plausible area. We don't have instruments that can measure interstellar gas and dust at that level yet, so we don't have a secondary way to verify this hypothesis. And we don't see this happening to any other stars in the field of view. You would think maybe other stars may be right next to it, maybe further, maybe a little closer, but would be affected the same way, and we don't see that either, nor have we seen this happening on any other star. So it's not proven. That is not the known solution. So let's go into our solar system, because the light has to get the last distance to Earth. It may have gone through the collision remnants of maybe a couple comets or asteroids in our solar system. And that would be why other star fields weren't affected. Maybe there's bad pixels inside the camera. And we've done lots of tests. The instrument was rotated on a regular basis to keep the solar panels pointing at the sun, and it showed up in the different sets of pixels, so that's not good either. So something catastrophically exciting like that is not very likely either. So what are we going to do in the future about Tabby's star? Interstellar gas and dust absorb blue light differently than they do red. And so we're going to look at the spectrum closer. Material right around that other star, even if something disastrous happened once, eventually it's going to start to become periodic. So maybe over months or years, we'll start to see some dips return, and then return, and then return. So we'll keep watching it for that. We have the upcoming Gaia mission, which is going to really measure the position of stars, a tremendous number of stars. Their parallax, if you put your finger out in front of you, open one eye and then switch to your other eye, you see your finger hop back and forth. Not many people are doing that. The Gaia mission is going to do that for millions of stars. So we will look at its position and see if that matches what we get from the spectrum of the star. And maybe it did swallow something and is artificially brightened right now. We are looking at the system using SETI tools, search for extraterrestrial intelligence, looking for laser pulses, radio, anything, HBO from the aliens. Nothing yet. And the TESS, Trans-Indian Exoplanet Survey Satellite, will look at the Kepler field 4 weeks at a time as it runs its mission once it gets launched. So maybe we'll catch more dimming and get more data. 500,000 possible stars that it's going to look at. Maybe other stars will be doing this too, just more subtly. So that's it for Tabby's star. Little news update. Best possible theory is clumps of stuff out in interstellar space, but alien megastructures are romantic. So if you could switch me over to the other. So any questions? Yes?
So you mentioned the Gaia. I'm unfamiliar with that. Is that something you can just...
It's going to measure the position of stars, lots of stars, very accurately. And it's going to give us a tremendous database of our neck of the woods in the Milky Way.
And how might that help you understand what's happening with the Tabby?
We have to make some assumptions of the distance the Tabby star is based on its spectrum and brightness. And this will give us a very accurate, independent way to know its distance. And if its brightness and spectrum are a little different, then we would know it probably swallowed a planet or something. Yeah.
How do you swallow a planet?
One bite at a time.
One bite, thank you very much. We can get planets interacting with each other, and we even believe that Saturn and Jupiter in our own system may have swapped positions in the early formation of the solar system. And so you can get gravitational interference, and one possibility is a planet can get ejected from the solar system. It'll also be sent right down into the star. So that is possible. Yeah. Any other questions? All right, so here we go into even more bizarreness. So, all right, so how many people have ever heard of
Can
it?
you give us a little dose of reality?
Yeah, a little dose of reality before real weirdness. How many people have heard of some little entrepreneur startup guy, Elon Musk? Okay, so this is kicked off. I've been working on information as the building block of reality, and even 7 years ago, I think, I gave my Theory of Everything talk here. It was the first talk. It was split up over 2 months because I had too much to say. And one section there was information as being the building block of space-time energy forces and all that you see around you. So that's been boiling around in my head. And when Elon Musk started doing the interview circuit, he started talking about, well, you know, me and my brother, we talk about it all the time. In fact, we've banned talking about it in hot tubs because otherwise that's all we would do. And that really kind of brought this whole thing forward. But as we'll see, there's an actual scientific paper out there that's had scientists thinking about this for well over a decade. Are you living in a simulation? And I have a compilation of 15 minutes of Elon Musk and also, gone from my head. Okay, I'll get his name later. That I'm going to play at the end. So after questions, after we're all done here, we'll just start a compilation of Elon Musk and, no, I thought I would trick myself into getting his name. Okay. So. Not Stephen Hawking, no. DeGrasse Tyson, there we go. Yeah. So he's in there too, yeah. So this is, the bigger argument here is called the simulation hypothesis. And tonight, this talk is going to be different than my other presentations that are just kind of science and what science says, because we're taking a step into philosophy here. And we're going to mix a lot of philosophy in this. And this is called a hypothesis, in that a hypothesis is a proposition you make for reasoning, and you don't assume that it's true. And if you do assume it's true, you do it for the reason of working out the implications of it. But you don't go running down the street with a newspaper up saying, this is real. So I'm not going to say this is real. I'm not going to say you're living in a simulation right now. But I'm also not going to say you're not. Now this is, a hypothesis is not as strong as a theory. A theory is really what we like to fuel science on. You got a system of ideas that explains something based on general principles, and we can go from there. You can actually look at this argument all the way back to Plato. Yes, we're going to the BCE years with the allegory of the cave and the idea that you have people chained up with a light behind them and they see shadows, and it could be their own shadows or it could be people walking by casting shadows, and they're trying to make sense of what reality is because that's all they can see. Of course, being a philosophers are the only ones that get to get unchained and go out and see what's going on. Of course, they get angry and don't believe what they see, and they're blinded by that light, but eventually they are glad they know the truth, and then they go back in to explain to the other people still chained up what reality really is, and they don't get believed. So, similar idea. Descartes comes along in the 1600s and asks, is the world real, or are we living in a made-up world? Could somebody be lying to us about reality itself? Now, he didn't have the pictures of computers and VR and stuff that we can put our brains around now, but his argument is pretty famous. It says, well, I'm still thinking, so if I'm thinking, I must be a thinking thing. We get, I think, therefore I exist. So what Descartes set out to do was to prove that all we see exists. He hit some problems doing that and conclude that he couldn't do it, but he could say something about his internal existence. He started with a total doubt that the universe exists and was unable to solve that. Well, does that mean the world doesn't exist as we perceive it? No, it does. We can all compare notes of what we see in front of the room, and our notes will all match pretty well. So it's useful sometimes to just build like a sandbox, where you build a structure and play with it all you want, and who cares if it falls down in the end because it was just made of sand. So we can have arguments, we can play with the ideas of whether reality is what we think it is or not, and see where that leads us. So if we go the other way around and start with doubt and try to prove the reality we live in is not the prime reality, we can assume that the reality is a simulation. created in some unknown way for an unknown purpose by unknown entities. And we'll see where this leads us. Now this idea has kind of gotten into pop psychology world out there, and people like to blame coincidences or bizarre behavior of the world or other people or maybe improbable events as proof that we live in a simulation. Because, well, that could only happen if this was all being orchestrated somehow. But this is not what this argument is going after. That's using it the wrong way. And we'll look at examples of why that is, but the bottom line is if we've got really good programmers simulating this, if they don't want you to know it, you're not going to know it. So they run the game. So this leads us to the philosopher who started this in a formal way, Nick Bostrom. I think I'm saying that correctly. At that time, he was at Oxford philosophy department. And he is not creating a formal argument. Again, this is not, we're not going to prove one way or the other whether you're in a simulation or not. But what he begins with is that no matter what you believe about reality right now, given the rate that we see technology going, one of the next three claims is certain. We're going to go through these claims, and I'm going to spend some time on each one and we'll see why he goes where he goes and why Elon Musk goes where he goes. But first, let's take a look at this rate of technology progress. We have a neat idea out there called Moore's Law. This is put in a 1965 paper. This is when I was born. He was working at IBM, and he noted that we were seeing a doubling of computational speed and a doubling of storage at half the cost of both about every 18 months. And if you think back 10 years, unless you're too young, we had pixelated, low frame rate, shallow color depth, hazy graphics, video games. I mean, way back we had Pong, as Elon points out in the video. And now you're getting things that are, the video game itself is live creating animation that is about as good as a theatrical cartoon. That's pretty amazing to be able to pull that off. Looking back to the year 1900 and going up to, extrapolating up to 2025, we can look at calculations per second that you can buy for $1,000 on this vertical scale. And way back here we have an analytical engine. What's that, John? Okay, there's an analytical engine. This is not as powerful as the calculator app that you accidentally delete off of your iPhone. So, and you can go up to an IBM tabulator, Bell calculator. We get the ENIAC here, IBM 1130. There's the Apple II, Atari 8800. There you go. The 286 IBM. There's the Pentiums up here, i7 quad core, and then the current winner, the Chinese computer, is it Tinhai? Does anybody know how to pronounce that? Tinhai 2 is up there. And maybe in the future we'll have optical or quantum or even DNA-based computing that takes us up here with the approximate calculation power of the human brain being up there. There's a mouse brain. So we've passed mouse brain and we're on our way to human brain capabilities. Of course, something like this takes up a warehouse, has its own power plant, uses river water to cool it, but then my iPhone here was a room-sized computer back here. So, according to Bostrom, one of these following three claims is true. Point one is the human species is very likely to go extinct before reaching what is a post-human stage. That is, we never get to the point where we can simulate reality. We can make conscious creatures in our laptop computers or our smartphones. So that's one. We never get there. So if that doesn't happen, then you're not in a simulation because we're in the prime reality, and then something horrible is going to happen. Point 2 is any post-human civilization is extremely unlikely to run a significant number of these simulations if you can do it, because either we lose interest in it or decide that it's amoral to run these. Oh, amoral, what does morality have to do with? Well, we'll talk about that. We'll get there. And point 3 is if the first 2 points aren't true, we are almost certainly living in a computer simulation. It's just statistics then. All right, so let's get into detail of these. So possibility 1 is closely related to the Fermi paradox or the Drake equation. Fermi says there are many planets and stars. Some may have gotten their act together billions of years earlier than Sol and Earth did. So where are all the aliens? Or we can extend this to where are the real humans that made simulations that we would be part of? And the Drake equation tries to estimate how many civilizations might exist in the galaxy. So you get the number of possible civilizations, you look at the average rate of star formation, how many have planets, and you get ecosystems onto life that doesn't kill itself off too early. You multiply all that together for an estimate. And when I first was teaching astronomy in the 80s, the estimations were down into maybe besides us, nobody, to besides us, maybe 1 or 2. More recently, especially with Kepler and discovering the ratio of stars that have planets and multiple planetary systems and planetary systems that are in the life zone, the Goldilocks zone around those stars, we've upped it an awful lot. Some say maybe there's 1,000 other civilizations, or maybe 100 million. Recent estimate kind of is in the 15 million. I'm not going to go through all the math of that, but I think maybe those are a little optimistic, but if you have that many civilizations and you can make simulations of other living beings, if that's something that the universe physics allows, then somebody's done it, if we haven't already. So from Fermi and Drake, we say, where are they? Well, maybe they don't want to talk with us. It's just a choice. Stop right there. Maybe they're disinterested. Maybe they're so far along mentally and technologically that we're just uninteresting. Maybe they would like to send an anthropologist out and study this little backwater planet in the Orion Arm, but maybe not. It'd be similar to how many people here want to right now spend money to get to the Amazon jungle, find a colony of ants, and figure out a way to communicate with the queen. I don't know. Nobody in this room, nobody's going to do that? Okay. So they're just, you got an organized structure that there's a lump of ants out there doing stuff, but nobody here wants to do it. And maybe they've decided ethically that we're not going to come and disturb us. This is like the Star Trek Prime Directive idea that until you've got your own warp engine, we're not going to come mess you up, unless you're the Borg. Maybe they're out there, but they're unrecognizable. Maybe there's something like the weird dipping of the light of stars that is a little message to us, and we're not getting the message at all. It just looks random to us, and we're blaming gas clouds. Or maybe we're too early. Maybe we are the first in this region of the universe to get it all together, and they're just not out there yet. But if some of these are true, then some of them may be far beyond us and have already been running simulations for all sorts of reasons. We'll talk about reasons that one would run a simulation of other beings in just a moment. So if we knew there were many civilizations, we'd be confident that someone has beaten us to it. Another possibility of point 1, though, is that maybe every time something horrible happens to those civilizations, you have disease, radiation, wars, solar flares, cosmic collisions that can end a civilization. we now are at a point where we can track an awful lot of the stuff in space around us. We aren't missing many, but once in a while something appears from the direction of the sun and zooms past us. We've had some pretty big rocks go between the geostationary satellite orbit and the top of the atmosphere. And we don't have a way to stop a big one yet. We have some ideas. We've got some movies that makes it look pretty easy, but it's not. And we have people who work to predict how our species might die off in the next 100 years. And when they say that the people who are prepping for the end are really ignorant of how bad it can get. So, and I should have a G in there, sorry. One of the big concerns, and Elon Musk is also one of those really worried about, he wants to get us to Mars, so we have another safe haven for humanity in case artificial general intelligence comes about. In fact, a growing number of scientists are concerned that beyond climate change and nuclear war, artificial global intelligence, something that is a artificial conscious entity, would quickly outstrip us and would quickly be able to kind of socially engineer us to get whatever it wants, stay under the radar until it owns everything. And I think it was Bostrom who went to, got a tour of Google and looked at the computing capacity of their centers, looked at all these rich, happy technicians walking around and went, if I was an artificial global intelligence and I wanted to have a comfortable place to live and stay incognito, I would probably get a whole bunch of rich, happy engineers crowded around me and big, beautiful office space to be in. So doomsday theory also says that we're more likely near the end than the beginning. If I had a box that either has 10 numbers in it or 1,000,000 numbers in it, and I reach in and pull a number out, and I get a 5 that first time, it is highly likely there are only 100 numbers in that box, just looking at the statistics of it. If you look at how many humans have ever lived, the best estimate I found is about 106 billion, which was about 7.2 billion people on Earth right now. It's 5.5% of all the Homo sapiens that have ever been alive are alive simultaneously right now. So let's say this little baby here is number 106 billion and one, then this theory would suggest that they're more likely in the smaller population that is at the end of the set than in one that's maybe going to be trillions of humans someday. Now, you don't have to believe that, but statistics always tell the truth, right? So before we go on from point one, we do need another definition here, and that is something called an ancestor simulation. I've kind of mentioned this, but this is a full simulation at a possibly highly accelerated pace that takes a computer program from early Earth all the way up to some arbitrary point in our future that would model all the weather, all the human development, all the geopolitical stuff, all the everything, all the consciousness, all the decisions, all the families, all of everything that has happened inside. And we're going to say, why would you want to do that? We will explore a bunch of reasons in just a moment. That takes us to possibility 2, that yes, they don't get destroyed by something. Yes, it is possible physically to do it, except, well, maybe. But we're going to, maybe because of ethical considerations, they never do it. All right, now what would that be? So we're going to bring up, make a hypothetical super leader that sometime in the future, before we're able to create ancestor simulations of all of humanity and run it for whatever reason we want to do it, we do get some super charismatic leader who can unify the earth in a decision to do something or not to do something. So as this technology progresses, and we get the ability to make ancestor simulations available to maybe everyone. You get your Earth 2.0 simulator that you can download from the App Store for $1. And in an hour, you've run all of human history for yourself. The ethical idea would be they have to go through all the suffering that people do. It means you're creating little conscious beings that are going to have loved ones lost, people get sick, horrible disasters happen, and the app crashed, you start it again. You've just done it all over again. Some may consider that to be a very unethical thing to do. So we have generations of creatures that you're making, little Sims here. Even if you want to hop in time traveler style, you're doing this for your entertainment at the cost of all the horrors and yes, the good things that happen being human that lead up to whatever point in the simulation that you're working in. Another side of the coin might be, though, that creating millions, billions, or trillions of living creatures that wouldn't have otherwise existed is a good thing. Just like planting more trees or planting more flowers outside, to create organization like that is good. All right? So this is an ethical issue. Can't answer it with science. So if you have a really smart phone and you're creating these little creatures inside, they don't have any say in the matter of being created. And we like better and better AI in our games today. I mean, if you're going to go around a first-person shooter and the bad guys somehow can figure out your emotions and get at you better, that makes the game more exciting, right? But you're also shooting those simulated people. So this is similar to the family planning debate, but on steroids. One argument from family planning debate is that should a person have some autonomy of choice over their body? Well, a simulation doesn't have a body, it's just the smartphone or the computer. When life begins doesn't come into this argument either, because once you turn on your simulator, there's life. The society may benefit by controlling the use of resources on the earth that are limited. Well, millions of new lives in your smartphone would hardly cost anything. You've already bought the phone, you're downloading the app, it's going to take a few dollars of electricity to run it. So that argument doesn't even come in. And one is creating millions and billions of copies of every life that has ever lived with these ancestor simulations. So these are Luddites here, smashing equipment. So maybe in the future, this will spark a global debate on the ethics of creating simulated beings, and maybe this super leader just says, nope, we're just not going to do it. This planet will not create simulators, and everybody goes, okay. There are other possibilities that would keep us from doing it. Maybe as we work to get brain interfaces with computers, we may come up with a way to not only pipe the reality to you that you want, but may be able to supply everybody with complete contentment and happiness. So with a population that's always happy, you don't worry about creating simulations and things like that. It just doesn't happen. This technological event, if it does happen, or even is possible and people do it, would keep us from playing with simulators. Other things like, well, circuses are in decline now. People more prefer to go to movies or video at home or play video games or get into virtual reality devices. And we, Barnum and Bailey, Ringling Brothers just closed down a couple of years ago, is that right? Last year. So what we consider entertainment and what we want to do does change over time. So we also might end up with the ability to reprogram human brains and mix you with technology, and maybe at that with that type of upgrade to the population, people may not want to play with simulations. It's possible. So we just don't know. There's something called the technological singularity that some futurists think is coming, like Ray Kurzweil is one really good author on it. And his point is, once you pass this point technologically, you really can't predict what humans are going to do, or what humanity will look like, or what the world will look like. So maybe we just don't know what is going to happen at that point, and maybe this strange point occurs in every civilization that could otherwise make simulations. There's other arguments about the hardware and our understanding of physics. We don't know what dark energy is, which is 70% almost of the energy content in the universe. We don't know really what dark matter is yet. We have indirect measurements of it, but it's a quarter of the energy budget out there. So maybe not being able to understand this, or understand how quantum gravity works, how quantum mechanics and general relativity work together, will keep us from being able to simulate full humanity or beings like this. So as long as we remain ignorant of the true workings of reality, we may not be able to recreate it. Others argue that really all you have to do is create enough to be convincing to people, and that's all the simulator would need to do. So that's an area of debate between engineers, physicists, and philosophers. So that takes us to point 3. If those first 2 points aren't true, if humanity survives, or another civilization out there survives long enough and can create conscious beings in a computer, then all that's left is that you are more likely than not to already be in that simulation right now. And that's where Elon Musk gets his argument on this. So why is this true? This statement true? There are people out there trying to prove that we live in a simulation, and that isn't what this argument is trying to do. It is just saying that if we can get to, and ever do get to the point where we can create consciousness, then there will eventually be trillions and trillions and trillions of simulated beings. There's only one prime reality, though. So I got Amazon Prime up here. So you have a 1 in a trillion chance of being accidentally still in the prime reality rather than in a simulation. That's as far as the argument goes. It doesn't prove anything. It just waves off in that direction and then leaves it to you to feel uncomfortable. All right, so it's just playing the odds. It's saying that if us or any earlier civilization in the universe can create conscious simulations, then the odds are nearly 100% that we're in one of them now. All right, so why would anybody make simulated beings? There's got to be a reason for that. Well, in our case, it may be unknowable. These intellects doing this may be, even if we look like them once in the past, their past, far beyond us to guess at what they're doing, just like the technological singularity argument. What could their goals and values and ethics be? Well, how do they view themselves in their relationship with the universe? We can't even guess. So that's uncomfortable. But there's other possibilities here. The black box theory. Maybe they want to try out some new invention or economic theory that could destabilize human civilization in this prime reality. So you turn on a simulation, you go in and you say, all right, we're going to increase in this country income tax by this much, we're going to increase tariffs over here this much. Oh, okay, look, that didn't work at all. And then you shut it off and you start with a different parameter. And so you're running simulations, but to do it realistically, you've got to have real people down in there. Maybe some feel that creating potential suffering so you can eliminate it is really good. So back to that supreme leader, if the goal of the planet is to eliminate suffering, maybe the more people you get that you can then relieve suffering from, then you are doing something ethically good. That's not a standard we have, but it is a conceivable standard that a civilization could have. The more the merrier. Just the belief that to create as much consciousness as possible is the best good. Again, doesn't match any clear-cut one that we have here, but it's a mirror to some of our cultural beliefs. This is probably my favorite one. If it can be done, someone will. So we're created because it's possible to. Then you got some more impersonal ones. Byproduct theory. Consciousness is the side effect of simulated reality that's working on some other problem in physics from some advanced version of us or some advanced civilization. And we're just kind of coming to be in there. So maybe physicists playing with the universe, they see limitations like the speed of light, or that it's understandable, like E equals mc squared is such a small, concise little equation that says so much. Or that maybe that life came into being at all, what we call the anthropic principle. These are seemingly built in to the world around us. Well, that may be because we're part of one of the many simulations with the parameters tweaked this way. It kind of goes into the parallel universe idea that physicists play with sometimes. Another reason why we'd be simulated is historians would want to recreate history. You can go out and dig up bones, and you can go and try to figure out DNA stuff, and you can do radiocarbon dating or radioisotopic data, dating of things, there it is. Or you could run billions and trillions of simulations with slightly different initial conditions and then find the one that looks like ours. You can hop in any place you want and go take video from any point in history. You've got it all in front of you. All of history is there for the historian to write down. Or just time travel and nostalgia. Maybe we can't time travel. I talked about that in a time travel talk a few years ago. But you could here. You could, if you're at the point where you can make a copy of your consciousness and just insert it in the 1950s and go drink a soda, you could do that. And this, goes into parallel universe, parallel processes. You could also play with alternate histories, kind of like the earlier modeling one. You could do what we do in fiction now, is that you pretend, like, Man in the High Castle, as running through a scenario where Germany won, and Japan and Germany divvy up North America, and there's a wasteland area in the Rocky Mountains, and it's pretty compelling fiction, pretty fun to read. They play with the idea that they have these newsreels in the TV version that seem to show bizarrely that the United States helped turn the tide against Germany, and Germany lost. Like, oh, what is that? Another could be artistic mining. If you run a million versions of history, all a little different, you can go in and get different stories, different versions of books. What if there's 500 versions of Gone with the Wind? You could go find a better one, or Casablanca with a different ending. One of these universes is going to create something else. Or maybe a universe where the Star Wars prequels are really good. Oh, I'm sorry. You could also get art and music creations that never existed, or find art lost to history that survived. Pull it out, sell it on eBay. Or gaming, a very realistic world full of artificial intelligent or artificial general intelligent creatures could be the best way to have a cool game. Ew. More impersonal than that, we are just part of a simulation. We arose accidentally. We don't know why it's being run by someone, but here we are. We're almost like the little virus buggy things that popped into existence. Or accidentally, similar to that, we arose on an alien computer network, or maybe a vast modeling system that's predicting how their star is running or something, and they don't even know that we're in here. Or maybe the universe itself is computational at its base. There isn't any intelligent being creating some simulation, but the universe kind of acts that way. where we seem to be running on bits. So how could these simulations work? All right. This argument that Bostrom was making can work whether we can create conscious beings in 10 years or 100 years, or if it takes 1,000 years for computer technology and software to get good enough to do it. It doesn't matter when, it only matters if it can ever happen. So if it can ever be done, then we're almost certainly in a simulation, is that argument. So by the numbers, there is an engineering plan that we could create a computer about the size of a sugar cube, not counting the cooling and power supply, that can perform 10 to the 21 calculations a second. That's a 1 with 21 zeros after it. It's a very, 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 very big number. We don't have anything that big. Our current top-end laptop is about 10 to the 12th calculations a second. That is trillions and trillions times slower. But the top computer on Earth today, 10 to the 19 calculations a second, that's a Tianhe 2, I think I did it better that time, which, depending on how you estimate the human brain is able to calculate, it's either close to or has surpassed the linear calculation ability of the human brain. And it has 10 times the memory capacity of the human brain. So if we're not there yet, we may have crossed over to where we have one external device as complex and calculationally rich as the human brain. Human brains are maybe 10 to the 14 to 10 to 17 calculations per second. We may have lots of redundancy, lots of noisy stuff going on inside, so maybe it would take fewer calculations to act like a conscious person. Not everything going on in us may be essential. If you made a planet the size of the sugar cube computer, I don't know how you'd power it or cool it, but if you could, you would get a whopping 10 to the 42 calculations per second. That's a pretty tiny area of the universe doing an awful lot of calculations. So what does it take to think like a human? Well, we only get about 10 to the 8 bits through our senses per second. That's about 10 megabytes. All that you're seeing, hearing, feeling, your stomach growling, whether you're sitting upright or leaning over, getting bored, listening to me, all of that's about 10 megabytes per second. That's nothing for phones and internet connections today. It was 20, 30 years ago. That's why MP3s were invented. So you could get a bootleg song off the internet when you had a dial-up modem. But we're way beyond that now. And we can't simulate the entire universe one-to-one. Otherwise you have a universe-sized computer, so that's not good. But what the argument is all conscious beings need is what they need to be able to perceive. Their internal thinking process and whatever they can get in through their senses. Once you do that, you can have a conscious being. What's a little interesting though, when you have a computer like this, my phone, the simulator wouldn't be able to take any shortcuts simulating the computer itself. You have to run through that in full speed. But computers today are really lightweights compared to this underlying computer that would have to be running our simulation. So how can this work? Well, maybe distant objects only get detail when you observe them. Maybe subatomic objects only appear to have a position and an energy and a direction when you observe them. So it's on an ad hoc basis. The rest of the time it can just sort of be approximated. Generate large objects like tables, but don't worry about electrons in detail. So looking at all of human history, looking at the total population of humanity that I showed, the simulation would need to run fast enough to generate around 10 to the 33rd to 10 to the 36th operations. That's from the first Homo sapiens sapien to everybody today. Every mental state, every memory, everything that they've ever done. Well, this planetary computer that I just invented out of sugar cubes could run 10 to the 42 operations in a second. So that's 100 million simulations a second from all of human history. 100 million human civilizations per second, just over and over and over, can keep running it. That is what the ancestor simulation idea is all about. So it's not running over weeks or years or centuries, it's running in per second. So can we see this? Well, like I said at the beginning, if there is an intelligent being or just bots created to look over the simulation to make sure we don't figure it out, well, people could be edited, memories could be erased, the simulation could be paused or backed up to get around someone discovering it. We could fix the brain states. I left that S yellow so I could say brain states. To anyone who might break the simulation somehow. And the simulation could be deleted and run from some earlier good save state if something glitches or breaks. So if all of reality is their playing field, we're not going to figure it out. So only if they want us to, or some rogue programmer decides to get in there. But again, how long is your life if all of human history occurs in a second? So that they would know that you're there. It would take an automation to figure that out. In simulation heavy locations, it may take more computational time to run the computer program. There may be algorithms that save space, like if you run a video game, some of the backgrounds and some of the shapes and the maps are all compressed. They get decompressed in the software for you to use, but only in the area that you're exploring and running around with. The rest of it sitting on the hard drive, compressed, taking up less space. Well, in the real world, where we see more matter, like a sun or a neutron star or a black hole, you have more stuff compressed into a smaller area. We do see time slow down. That's general relativity. Or if you start going up near the speed of light, time slows down. So you have special relativity. So that does act like a simulation. Compression algorithms might be used to save space. If there was some configuration that you could compress atoms down into that they don't obey for some reason, it's possible you should stack them that way, but they just won't go. Maybe we will have discovered the compression that the simulation is using. You can't zip a zip file. If you do, it doesn't get any smaller. So those are some possibilities that we see. Like I said, looking at distant objects or subatomic objects and it just appears when you observe it, well, that's what we may call the wave function collapse in quantum mechanics. Or once you get telescopes big enough and you can see out in the universe, suddenly there's a bunch of detail there. When you look in that direction with Kepler, now you're seeing planets going around stars in that one spot. How about breaks or inconsistencies in the simulation? Some claim to see glitches or memory problems or something called the Mandela effect, that everybody remembers something wrong about history, but when you go and look, hey, no, it didn't happen that way. Well, maybe that's some little errors in our simulation. Some people explain deja vu this way. That showed up in the movie The Matrix with the black cats glitching and showing that agents had entered the simulation. Some look at the simultaneous scientific and engineering discoveries or even artistic creations where you have, like, calculus was discovered by Leibniz and who's the main guy? Newton, thank you. I know the secondary one. Or we had evolution from Darwin, but also Wallace. We have things in science that two different independent discoveries seem to be made. Or you could just say the field was ripe for the next discovery. All the other pieces were in place for them to connect the dots to create that. We might, when we really get to look around black holes and see close to the event horizon, maybe we'll find energy budget errors or something that will give away that there's a rounding error occurring in the calculations of the simulation. We don't know. That's a possibility. So when will we know if we actually are in a simulation? Well, if we can create a simulation, if it's possible to do that, then point 1 of Bostrom's argument is false. The moment we turn it on, point 2 is false, and now you're nearly 100% of being the simulation, creating a simulation yourself. Yeah. That leads to my Elon hypothesis. Elon Musk is a billionaire. He can date women around the world on his private jet. He owns his own car company, rocket service, Boring Company, created PayPal, created OpenAI, Solar City, Neuralink, which is an interface with the brain he's working on, battery company, I guess now a news organization he's starting. So maybe Elon Musk is the only real player in the simulation, and we're all the simulations that he interacts with. He's even telling us that we're in a simulation, and we're just not believing it. So I don't know, I don't believe that. But, all right, so looking more at the world around us, what do we see about the world that looks like a simulation? Well, James Gates here, he's shown up as a talking head in Brian Greene's Fabric of the Universe and Elegant Universe, Fabric of Cosmos, Elegant Universe videos with Nova. And he says he's discovered strange error-correcting codes deep in the equations of supersymmetry that he's working on. And we'll see him if you stay after the question and answer part, he's talking with Neil deGrasse Tyson. Yeah, I got the whole name that time. Talking with him on stage. So that's one of the interviews that's in that video cobbled together. Ringel and Kavritsky, oh boy, go the other direction. They look at a computer simulation of a quantum phenomena where you're stacking electrons in a metal, and they say it's impossible that the universe could be a simulation because computers can't calculate that fast enough to get to any size. If you get 200 electrons into the simulation, you would need a computer larger than the universe to calculate that. So they say the real world is doing something that computers can't. Yes? Oh, just stretching? Okay, I had a question. It's a good stretch. But maybe the just-in-time simulations come to the rescue here, and we're just given an answer that we want at that time. I don't know. So there's an idea of some of the calculations that they're working on. Another way to look at this is to see if space-time is digital. If there's a graininess, like the memory spots in your RAM would have. And there's experiments doing this. The MAGIC, the Major Atmospheric Gamma Ray Imaging Cherenkov Telescope, was looking at high energy particles coming from distant sources in the universe. As it travels through the universe, if space-time had a graininess to it, it would act on that high energy light the same way that a prism works on a normal beam of light, letting light at different frequencies go through at different speeds. So you would get the higher energy versus the lower energy part of that burst spread out over time. And they claim to see that, proving that space-time does act memory-like, that the speed of light varies based on the graininess of space. But, of course, other experiments have already come along looking at the polarization of light from distant gamma rays and contradicts this. So we're still left with, I'm not sure. John Wheeler is famous for the statement, "it from bit." Does the stuff in the universe around us look like information in a big program? All right, so before going on, who wants to tell me what information is? We have a definition for information. Is it just ones and zeros? No. Amount of stuff stored on your phone? Amount of email you have to delete? No? No answers? All right. It's the measurement of the number of alternatives for something. That's how we'll look at information. Meaning, value, or how much email you have, doesn't figure into this basic definition of information. Claude Shannon at Bell Laboratories in 1948 started the ball rolling in something called information theory, and that's kind of rolling through all the sciences right now. Even in biology, now we can sequence the DNA. You got 4 letters making up the genetic code. You got RNA with its 4 letters, and we're piecing together biology totally from a information level up. So if you have a die, you have 6 possible outcomes, you have 6 bits of information. Your birthday, 366 possible outcomes. Once you know that, you got 366 bits of information. So what information allows us to do is distinguish one way a system is from another way. It also is a way that different parts of systems communicate with each other. Information in this way builds reality. It tells you something is versus isn't, and tells you how it's built. It tells you how this group of atoms is arranged in this configuration and not any other. And for the most part, light, but now we use gravity and neutrinos and other things, but we use stuff that travels across the universe to tell us about what it came from or what it bounced off of. The color of the sea contains information about the color of the sky. The cell here has information about the virus that's attacking it. Your ears are telling you things about what's in my brain through this intermediary of sound. Every part of information contains echoes of the stuff around it. Even the temperature of empty space around the Earth says something about the Big Bang leftover microwave background energy. In quantum mechanics, any description of a system says how they're correlated with everything else around it. You can get into things like quantum entanglement and cool concepts like that. But to all sum up, quantum mechanics again takes it from bit. Everything that exists is information. Okay, so what if this is a program, then what makes this data flow? And you'd say, well, time has to tick by. But actually, time doesn't seem to exist. When you really get into it, all of the equations of physics, except one set, don't care about time. Special and general relativity work forward and backward just the same. Electrons interacting with each other, protons bouncing off each other, look the same forward and backward. In a way, you can look at a disk like this and say, here's the inside edge is the past and the outside edge is the future. All of history is right in front of you right there, right now. Time is making it turn and playing through it. Where time does matter is when you start getting heat to flow. If you get something that can warm up or cool down, then time starts moving. In the big world, near a planet, you get up and down mean something. When you get many molecules, they can be hot or cold, and hot and cold has meaning. So what we find is time is related to heat, and it takes a lot of little things together to give you the temperature of something. Anytime you have things happening where heat doesn't change, you can turn the clock backwards and the thing happens perfectly fine backwards as forward. If heat figures in, then things can't be reversed. Then you have a forward direction in time. So if you throw a rock up and down in a vacuum and play the film backwards, no one would be able to tell which way the film playing is normal. But if the rock hits the ground, it's going to make a sound, it warms up the ground a little bit, you get a little warming there. So when you play a video backwards of a rock that suddenly hops up off the earth into the air, you go, well, that's not right, because some heat exchanged right there. So little chicks don't go backwards to become eggs. Candles burn and produce smoke, but the smoke doesn't go back in the candle. A boiling pot of water cools and doesn't heat up again by itself. Machines wear out and don't self-repair. We get old, the sun's getting older. All those things are where heat is moving. So we need to ask how time allows, not how time allows heat to move around, we need to ask how does heat produce time? Reality is a network of relations. Time is not necessary, but it comes when there's communication of information and loss of information, dissipation of heat. Time is the running of the program of this network, and the network acts like a computer program. So I did a big section on information theory, I said 6 years ago. If you want to go back and see the video, it's out there, I believe, still on Theories of Everything. Yeah, I think it's still there. So you can go back and look at another play through information and entropy, but I'm not going to go into that here. I'm going to finish up with what are the dangers of living in a matrix if we are? Well, the simulation might crash, but you're not going to know it. You're just gone. If we fail, if there's a goal in the simulation, we might get shut off. But if you don't know what the goal is, what can you do? If we're not interesting enough, we might get shut off. I think we're pretty interesting. I mean, it's a personal opinion. When we're about to create our own true simulations, it might cost too much. So when we're about to turn on our own simulations, and we're already simulations, or maybe we're the 8th level down of simulations, creating simulations, and go, hey, we can't let this last level do it. That'll break the computer. Then we get shut off. So maybe the day we turn on our first conscious little critter in a computer, gone. We also might be forgotten, and the simulation might go off the rails. I think you'd probably see the universe like tearing apart or something. I don't know what you would see. But if the simulation continues and we create artificial intelligence, some futurists are saying that might arise and destroy humanity. Well, then what happens? Well, we might want to upload copies of ourselves to keep up with the artificial general intelligence. Or we might come up with interfaces with computers to keep up with the AGI. And there you see another motivation behind Elon Musk and the neural net and the artificial intelligence research he's doing. He's all over this. This is kind of the background of all that he is starting with his billions of dollars. And putting a second version of humanity on Mars in case the first one crashes is part of the same thing. So we've kind of gotten into a psyche a little bit right there. So if we are in a simulation, what should I do about it? Well, nothing, unless you're a physicist working on measuring reality as accurately as you can, and you're looking for these glitches. You have lived your entire life believing you're real, and this takes us back to Descartes. You think, so you are. Finding out you're totally wrong about reality doesn't change anything about your reality. You still have your past, and you still have your future. People of the 1200s were really wrong about how reality worked, but life went on, and you milked the cow, and you invented the printing press and the calculator, and onward. So Bostrom's final line is, unless we are now living in a simulation, our descendants will almost certainly never run an ancestor simulation, flipping it backwards. So if you want some further reading, listening, there's a lot of material out there on complexity, information. I really enjoyed the Philosophize This podcast, where they actually have a Are You Living in a Simulation episode. Bit in the Pendulum, Reality is Not What It Seems, Island of Knowledge, Information Theory, that's kind of thick. And Elon Musk is available at YouTube any time of day or night. All right, so before we play him for 15 minutes and you guys run to the telescopes and enjoy looking at the real universe, any questions? Yes?
What is your theory?
I knew that was coming up. I think it's more likely than not that we are, because I don't see point 1 or point 2 being limitations. I don't think we're going to destroy ourselves. Maybe I'm an optimist. And I do think that we can make simulations. I don't think that there's a physical reason why simulations can't be made fully conscious inside of a computer system. Maybe nothing now that we have, maybe nothing we will have for a century, but I think that someday that it'll be possible to have conscious beings that are self-aware, that have the looping feedback circuitry that allows them to not only think about what's around them, but think about what they think about what's around them, and think about the fact that they're thinking about the stuff around them, and all the stuff that leads to a sense of I.
So is God the prime reality?
Is God the prime reality? That's a good question, because I'm a Christian. So I would say no, probably beyond. Beyond prime. Yeah. But I'll have to go talk to my pastor about that. I say, John, what are you saying? Other questions? Those are some hard ones there.
How does cloning work into this?
Cloning? Well, there's physical limitations so far in cloning with the length of the telomeres and things like that. Since cloning ultimately is just information in a DNA molecule, we're still crudely at the level where we can engineer DNA. I think we've made a few fully simulated, not simulated, that's the wrong word, fully artificial cell structures. I think we've had to create that and stick it into the cellular cytoplasm of existing bacteria after taking the nucleus out of it, but they've kept it alive that way. But we're just in the very baby infant years of being able to manipulate things on a molecular scale. Certainly given time, that'll become child's play. So you'll be able to make multiple clones of any cell you want and like that. Over time, it will diverge from the primary. You have everything from gene expression to environmental influences to whatever you eat and take in that changes how things work. So, clone is a clone, but still basically a twin, and would be going its own way pretty quickly. It would have its own set of memories. It'll, of course, be way behind you in development. It's not like Star Trek where they age everybody up to a full-grown actor age in a week. You would have a mini you out there running around. So. Other questions?
Is this part of the foundation of multiple universes?
The thinking that goes into multiple universes is applicable here in many ways because you would have multiple simulations side by side. And if the operating system up above would let you hop or exchange places, then you could do the things that we do in science fiction or have fun with it. I don't see any evidence of that possibility, but maybe just, I don't know what I'm looking at. So, any follow? Did I answer that? Okay. Yeah, and in some models of parallel universes, the universe itself looks flat. The curvature of the universe is nearly zero to what we can measure, which implies that it's really, really big. And I don't remember the number exactly. It's like 10 to the 10 to the 51st power meters away from you, or 10 to the 100 to the 51st power, something like that. Yeah. I don't remember that number. You run out of configurations of space and particles and energy within the bubble of our observable universe. And it will repeat eventually. And so someplace out there, 10 to the 51, whatever that number is, there is an exact copy of us doing this exact thing in this exact room, in this exact universe, because you have to. Statistically, there's no other way to do it. Every possible combination will happen in between. And then beyond that, another and another and another in an infinite universe. So just that model of infinite universe, there's a whole bunch of views out there. So, and in between, there's every other version of you and a bunch of nothings. So, yes?
Any favorite science fiction that you've read or movies that you've seen along this line?
Along artificial intelligence lines? Yeah. I wasn't prepared with that name. There's one, oh gosh, what's his name? It's like Vigo, I'm trying to remember the author's name. He's a futurist science fiction author, and I'll have to email it to you and have you do a subtitle or something. But yeah, he's written, okay, you can look him up on the web. He's the person who coined the term technological singularity. So boy, it's not coming to me. So he's got a number of interesting fictional books in which he runs up to the point of singularity. His idea is you really can't take fiction beyond the singularity because you have no idea what, like I said before, the values, ethics, goals, desires, and abilities of a post-singularity civilization look like. It's once you go through a singularity, you can't tell how all the stuff is going to come out the other end. So he plays right up to the edge and has fun showing the rapid acceleration in the end of technology and society's creaking and groaning under the strain of change. So. All right, any other questions, thoughts? Okay, how many people are in a simulation then? Okay, we got 1, 2, 3, okay. Those are the player characters right there. So. All right, thank you very much. And if you use the mouse to hit the play button, we'll let Elon go for 16 minutes here. And